In the heart of the coldest and most desolate continent on Earth, a geological anomaly breaks the monotony of absolute white. In the confines of Antarctica, where the silence is only interrupted by katabatic winds, a crimson flow makes its way through ancient ice. It stains the snow with a dense hue that inevitably resembles fresh blood. For over a century, this phenomenon baffled early explorers and defied biological expectations in an environment of perpetual freezing. What we observe is not an optical effect or a temporary illusion. It is an active geological record, a direct window into a subterranean ecosystem that has remained hidden, operating in absolute darkness. We are specifically in the McMurdo Dry Valleys, one of the most extreme and arid regions on the planet. Unlike the rest of the continent, it barely snows here, and the winds sweep away any trace of moisture, creating a landscape that scientists frequently compare to the surface of Mars. In 1911, Australian geologist Griffith Taylor discovered this peculiar waterfall while mapping the area on a pioneering expedition. Upon observing the intense red color staining the base of the enormous glacier that today bears his name, the first conclusion was logical and prudent: red microalgae. At that time, it seemed the only plausible biological explanation to justify such pigmentation in such a hostile environment. However, early 20th century technology did not allow looking beyond the surface, leaving the true nature of the liquid on an investigative pause. Visually, the Taylor Glacier presents an immense fracture at its advancing front, from which this continuous and unsettling flow emanates. Imagine a massive ice wall, about 5 stories high, composed of pure white and deep translucent blue. This immaculate structure is vertically torn by a cascade of dense, dark, and rusted liquid. The visual contrast is absolute and fascinating. At ambient temperatures that routinely drop below -20 degrees Celsius, surface water should be completely solidified. The freezing wind lifts thin layers of dry ice around the waterfall, while the crimson liquid slowly advances. It crystallizes at the edges, but maintains a surprisingly fluid core. The textures of the surrounding ice show deep cracks and evident mechanical stress patterns, indicating that the enormous glacier is in constant and silent movement under the immense pressure of its own weight. For many decades, the international scientific community accepted the red algae hypothesis as a proven and settled fact, but advances in modern spectrometry and deep drilling techniques revealed a much more complex and fascinating subterranean reality. The liquid emerging to the surface contains absolutely no algae. It is, in reality, a brine extremely rich in dissolved iron, and the most shocking part is not the chemical composition itself, but its hidden origin. For liquid water to flow freely in this environment of extreme freezing, there must be a deep source. Recent radio echo soundings revealed a vast network of interconnected fissures and a large subglacial lake trapped beneath 400 meters of massive ice. This is a very ancient aquifer that was completely isolated from the outside world approximately 1.5 to 2 million years ago. The internal mechanics of this subterranean waterfall are an astonishing testament to chemistry operating in extreme conditions. As the original water of the ancient lake slowly began to freeze millions of years ago, it expelled salt from its crystalline structure. This process, formerly known as cryogenic exclusion, created a brine that is approximately 3 times saltier than modern ocean water, drastically lowering its freezing point. The dramatic red color appears when this brine, loaded with ferrous iron, finally reaches the surface and comes into direct contact with atmospheric oxygen, oxidizing almost instantly to form ferric iron. But detailed chemical analysis revealed something even deeper and more revealing: clear isotopic signatures of continuous biological activity. In total darkness, with no access to fresh oxygen and at sub-zero temperatures, a network of chemosynthetic microbes survives. These extremophile organisms extract vital energy from sulfates and iron, breathing solid minerals instead of oxygen to sustain their existence. Despite understanding the fundamental chemistry of the water, the basic physics of the glaciers posed an obvious analytical obstacle. How can a liquid, even being a highly concentrated brine, flow through hundreds of meters of solid ice at temperatures that should hopelessly solidify it? The answer was recently confirmed using high-precision thermal sensors introduced directly into the glacier's fissures. Water releases energy in the form of latent heat when it changes state and freezes. As a small fraction of the water crystallizes on the cold walls of the cracks, the exact and sufficient thermal energy is released to warm the surrounding ice. This subtle latent heat melts the ice just enough to allow the brine to continue its ascent. It is a self-sustaining thermodynamic system. This extreme and isolated ecosystem not only redefines our modern understanding of terrestrial biology, but it drastically expands the horizons and hopes of astrobiology. If cellular life can sustain itself uninterruptedly for millions of years under an Antarctic glacier, in complete darkness and extracting energy directly from rocks, the implications for space exploration are immense. Environments that we previously considered sterile, such as the deep subsurface of Mars or the vast liquid oceans hidden beneath the thick ice shells of the moons Europa and Enceladus, suddenly seem much more hospitable. The Bloodfalls acts today as a perfect terrestrial analog for these alien worlds. It provides researchers with an invaluable natural laboratory to empirically study how microscopic life could survive and evolve in the coldest and darkest corners of our solar system. The Bloodfalls in Antarctica is not an unfathomable mystery, nor a phenomenon that defies the laws of nature. It is the precise and measurable result of geology, chemistry, and biology operating together at the most extreme limits of the possible. It visually reminds us that Earth still harbors intact time capsules, ecosystems that have evolved in parallel to the surface for eons. By observing this crimson flow staining the perpetual ice, we do not only look directly into the geological past of our planet, but we catch a glimpse of the unbreakable tenacity of life itself. It is a silent but relentless force, capable of adapting, resisting, and thriving in absolute darkness, patiently waiting for the right geological moment to emerge into the light. Subscribe to uncover the secrets Earth is still hiding.